Assalamualaikum guys. Okay, we are back. We're still in special probability distribution for discrete random variable. Okay, last week we had looked on the binomial distribution. So this week we are going to cover on the Poisson distribution. Okay, so how to identify a Poisson distribution? Okay, so a Poisson probability distribution for the number of occurrences in a given interval. Okay, so please take note on this term, number of occurrences. Okay, in a given interval, okay, must satisfy the following three conditions. The number of occurrences is a discrete random variable. The occurrences are random, the occurrences are independent. Example for Poisson distribution is that the number of computers sold at a shop during a given week. Okay, so kalau you tengok kan, the number of computers sold at a shop, okay, this one could be a binomial, okay, tapi you have an added breakdown, okay, which is dia punya occurrence ni is in a given interval. So contohnya in this one during a given week, so dia ada interval kat situ. So dalam in a week, so how many computers are sold, okay. So kalau if you have the interval, meaning that this is a Poisson distribution, okay. Otherwise, if you have no interval for the occurrences, that would be only a binomial, okay. So kalau you ada the number of defective items in the next 50 items manufactured on a machine, okay. So you have the first 500, the second 500, the third 500 items produced, okay. So dia ada macam interval kat situ. So this is also a Poisson, okay. And then the other example for Poisson is that the number of customers entering a supermarket during a 2-hour interval. So it can be in 1 hour, in 10 minutes, in half an hour. That's how you identify the Poisson distribution. Okay, so okay, let's have a look at the PDF of Poisson distribution. A random variable x is defined to have Poisson denoted by x follow p of lambda. Okay, so lambda is your parameter for Poisson. Kalau binomial, we write it like this: b, n and p. Kan, n is the number of trial, p is the probability of success. So kalau for Poisson, you have the lambda. Okay, so lambda is actually the mean number of occurrences in an interval, and lambda should be greater than 0 lah. Okay, so it is given, the PDF is given by this: lambda power x e power negative lambda over x factorial. Okay, so x is the number of occurrences. So contohnya you nak cari x is the number of computers sold in a week, so you nak cari the probability of 3 computers sold in a week. Okay, so you cari px equals to 3. So, yeah. Okay, so the mean and variance of a Poisson distributed random variable is given by lambda, and the variance is also given by lambda. Okay, so kalau macam binomial, okay, what would be your mean? Np. Your variance will be npq. Okay, so kalau Poisson dia lagi senang lah, that's just equals to lambda. Okay, now discussion. Okay, consider the arrival of patients at the physician's office in a day. Okay, and the second situation is that the arrival of airplanes at an airport in a day. So now, do you think they follow Poisson distribution? Okay, so kalau you tengok consider number of arrival of patients. So arrival of number of patient arrive in the physician's office. So they are discrete kan? Okay, so they discrete. Okay, so kalau you tengok there's the occurrences is in a given interval, which is in a day. Okay, so ada interval. Okay, so possibly situation 1 ni is a Poisson. Yang situation number 2 ni in a day juga kan. So there's a interval of occurrence, the arrival of airplane. Okay, so what do you think situation 1 and situation 2 follow Poisson distribution? Okay, so let's check back the condition to satisfy Poisson model. Okay, so the first one dia kena discrete random variable. Okay, occurrences are random and independent. Okay, so kalau you tengok at this situation, okay, dia sebenarnya the arrival of patient at the physician's office, if it's kalau the office is given an appointment, okay, so kiranya dia send out dia dah ada appointment schedule lah. Okay, pukul berapa sekian-sekian, satu hari dia akan bagi appointment berapa banyak je, macam 30 orang aja. So maksudnya the arrival of patient kan would not be random kan. So that is the random tu is one of the condition to satisfy Poisson distribution kan. So kalau ada appointment, it's not random, so therefore it is not a Poisson, if appointment has been scheduled ahead lah, ahead in a day, okay, in a particular day, okay. Alright, the second situation is that the arrival of airplanes kan, selalunya pun sama juga, it's not random, betul tak? Sebab selalunya the airlines has scheduled all the flights that has been that were going off and in a day, okay. So the occurrences of the arrival of plane is also not random. So this situation 1 and 2 are not following Poisson distribution, okay. So that is why. Okay, apa aku buat ni? Okay, so now let's look at the first example for Poisson distribution. Assume that the average number of computers sold at a shop per week is 10. Find the probability that 5 computers are sold in that shop per week. Okay, so kalau you ada it's a number of X ni you define as a number of computer. Okay, so X is a discrete random variable. So patutnya dia kata find the probability that so you have the occurrences in a given interval, which is in a week kan, in a week. Okay, so X would follow Poisson with what? Average, mean, lambda is your mean kan, average number of lambda is your mean, which is the average, would be 10. Okay, so you would want to find the probability that 5 computer are sold. Okay, X equals to 5, so you akan guna the formula lah. That would be 10 to the power of 5 e negative lambda, which is 10 over x, which is 5 factorial. Okay, so you calculate, you're gonna get 0.03783. Okay, alright, so now find the mean and variance. Okay, so your mean will be equals to lambda, which is your 10, which is equals to 10, and your variance is also equals to lambda, which is equals to 10. Okay, so similar to binomial distribution, okay, we can also find the Poisson probabilities from the Murdoch and Bunch, okay, the statistical table, okay, ataupun you can use your calculator. Okay, let's have a look at the example. X follow Poisson with lambda equals to 3. Find the probability that Px equals to 2 using formula and table. Okay, so kalau for the first Roman, you have lambda equals to 3. So using Poisson formula to get Px equals to 2, you will get 3 to the power of 2 e of negative 3 over 2 factorial. Okay, so you will get your answer as 0.2240. Okay, so kalau you want to find Px equals to 2 using table, okay, so we have a look at the table here. Table, okay, so table here. So if you want to find the Poisson probabilities, okay, so tadi we have lambda equals to 3 kan, okay. Let's read the table, the notation using in this table. The table gives a probability that R or more random events are contained in an interval when the average number of such event per interval is M. So tadi kita guna lambda kan, tapi dalam table ni dia denoted the lambda tu as M, okay, and XU as R, okay. So when there is no entry for a particular pair of value of R and M, this indicates that the appropriate probability is less than 0.00005. Okay, so that means the probability will be really, really small. So they don't tabulate lah in the table. They tabulate up to 4 decimal saja. Okay, so tadi our lambda is 3. Okay, so let's have a look. Lambda 3. Okay, lambda 3 is over there. Okay, here. Okay, and then you want your R lah, which is your X, is equals to 2. So your answer will be 0.8009. Tapi kenapa dia tak sama? Tadi kita dapat kosong guna formula 0.2240 kan? Oh, okay. So, you tengok the table gives the probability that are or more random variables. So, maksudnya, okay, kalau if you want to use the table, so to get Px equals to 2, you kena tolak Px greater or equal than 2, tolak Px greater or equal than 3. R greater than 2 will be just now berapa tadi? Kita tengok 0.8009 kan? Greater than 3 will be 0.5 berapa tadi balik 3 kan. Okay, so 3 will be 0.5768. Okay, 5768. Okay, so you akan bila ditolak you akan dapat 0.2241 macam tu lah. Okay, so beza dia yang ni this is 0.2240, yang ni 0.2251. Okay, so it's quite close lah. Okay, alright, so number 2 Roman, you want to find Px, you want to find Px greater or equal than 3. Okay, so kalau you want to use table kan, okay, you kena tambah Px 3 plus 4 plus 5, and you don't know how many apa ni x lah that you would have. So instead kalau nak senang kira, you do 1 minus P x less or equal than 2. Okay, so you ada 1 minus of Px sama dengan 0 plus Px sama dengan 1 plus Px sama dengan 2. Okay, alright, tapi ni kalau you nak guna formula, you gunalah yang x equals to 0, you gonna have 1 minus 3 power 0 e power negative 3 over 0 factorial, tolak lagi 3 power 1 e negative 3 over 1 factorial, and macam tu lah. Okay, so nanti you akan dapat 0.6472. But if you want to use the Poisson table, the table gives you the occurrence of having R greater or equal than R kan. So you tengok je. Okay, the table gives you 3 kan. R 3 is 0.5768. Okay, so you gonna have sorry, yang ni salah. Okay, ni 0.5768. Okay, so from the table pun you akan dapat exactly the same from table as well kan. Okay, alright. The third Roman ni macam alah boring je kan. Kita buat yang 5 Roman lah. Okay, 5 Roman, you want to find Px in between 2 to 5. Okay, which means 2 ni not included kan. So maksudnya you only want x from 3 to 5. Okay, so kalau you want to use the formula, you kena tambah lah x3 plus 4 plus 5. Okay, tapi kalau you want to use the table, Px greater or equal than 3 tolak Px greater or equal than 6. Okay, so kalau you tengok the statistical table, x greater than 3 tadi, you gonna get 0.5768. Okay, you tolak Px greater than 6, you akan ada berapa? 0.0839 ni. Okay, 0.0839. So you will get 0.4929. Okay, alright. Tu je lah kot. Okay, cukup lah. Yang lain semua it's kind of same. Okay, alright. Okay, let's have a look at another example. Okay. Okay, so you have a department store sells average 3 electrical appliances per day. Okay, assume the sale is a Poisson distribution. Find the probability that on a given day, the store will sell exactly 4 electrical appliances. Okay. So kalau for A ni, okay, you have x follow Poisson lambda equals to 3. Okay, x is a number of electrical appliances sold per day. Okay, so I'll just write here x is the number of electrical appliances sold per day. Okay, so you want to find A, Px sama dengan 4. Okay, so you can choose to use the statistical table or the formula. So kalau I guna formula, table, Px greater than 4 minus Px greater or equal than 5 lah. Okay, so I will get 0.3528 minus 0.1847. Okay, you tengok statistical table lah. Lambda equals to 3, R equals to 4 and 5. Okay, so you will get the answer. Okay, yang A 2 Roman. Okay, at most 5 electrical appliances. So at most 5 is the maximum is 5 lah. So you akan ada, it can be lesser than 5. Okay, less or equal than 5. So if you want to use the statistical table, this will be equals to Px greater or equal than 6. Okay, so you can check it out on the statistical table, lambda 3 x r equals to 5, so you will get, so r equals to 6, sorry, you will get 0.0839. So your answer will be 0.9161. Okay, so 3 to 8, meaning that yang ni 3 Roman x from 3 to 8. Okay, so to use the table, yang table gives you r or more kan, so greater or equal than 3 minus px greater or equal than 9. Okay, so you will get your answer as 0.5768 minus 0.0038. Okay, so calculate 0.5730. So that's your answer. Okay, yang ni berapa? 0.1681. Okay. Alright, so now for B, okay, find the property that on a given week this store will sell. Oh, okay, so kalau you tengok the interval of occurrences yang ni, you will get average of 3 electrical appliances per day. Okay, tapi for this question dia nak property that on a given week. So you ada different interval. Ini satu hari, ini satu minggu. Okay, so one of the characteristic of Poisson distribution is that the interval where the frequency is counted, such as per hour, per day ke, per week ke, per month ke, they are proportionate sebenarnya. Okay, so apa ni, kalau you have 3 electrical appliances sold per day, okay, so ini per day. Kalau per week means you akan ada ni average kan, average 3 electrical appliances sold per day. Kalau per week, what would be the average? Sebab dia, like I said just now, it's going to be proportionate. So you akan ada per week will be 3 times 7 lah, 7 days. Okay, so you akan ada 21 electrical appliances sold per week. Okay, so now we can define y ni as the number of electrical appliances sold per week. Okay, so tadi kita dah kira kan, so because it's proportionate, satu hari 3 appliances. So kalau seminggu 7 hari will be the mean akan ada berapa, 21 satu minggu. Okay, alright, so right now untuk B ni kan, you would want to find the property that on a given week this store will sell exactly 6 electrical appliances. Okay, so P, instead of using X kan, X is electrical appliances sold per day. Now we're looking at Y. Okay, Y that is exactly 6, okay, per week kan. Okay, so this would be Y greater or equal than 6 minus PY greater or equal than 7. Okay, so you go and check out on your statistical book, lambda 21 ada tak kat sini? Ada tak 21? Ada 21. Okay, so you want R equals to 6. R equals to 6, tengok the probability will be 1. R greater than 6 is 1, R greater than 7 will be 0.99999. Okay, so kalau you tolak, okay, so this one will be 1 minus 0.9999. Okay, so you will get 0.0001. Okay, next one, you want to have on a given week this store will sell at least 15 electrical appliances, so greater or equal than 15 lah. So you look at the statistical table, lambda equals to 21, R equals to 15, you're going to get 0.9284 kan, so the probability is high. Okay, 3 Roman, more than 8 electrical appliances sold per week. Sorry, ni bukan X, ni Y kan, dia different interval, this is per week. So you want to find PY. What is Y? Y more than 8. More than 8 is actually more or equal than 9, sebab dia discrete random variable kan. So you will get 0.9989. Okay, so that's how you do it. Okay, alright, so yang discussion ni I think we can discuss during the live lecture. Okay, so that's all for Poisson distribution. Okay, so please have a look at your tutorial, and then nanti during the live lecture nanti kita do a little bit of activities to differentiate whether a particular situation is following binomial ataupun Poisson. Okay, so remember, let's recap. So differences between Poisson dengan binomial, both of them are discrete random variable. Tapi okay, so let's recap. Okay, the similarity between Poisson dengan binomial distribution is that they are both coming from discrete random variable. Tapi differences here is that Poisson ni there is a occurrences kiranya tapi bezanya Poisson ni there is an interval involved in a number of occurrences. Okay, so contohnya per week, per day, a year, whatever lah. So dia ada macam ada interval. Okay, for Poisson. Binomial dia tak ada. Okay, alright, so that's all for this week. So I'll see you during the live lecture. Okay, bye bye. Assalamualaikum.